All right, Math 8. Here we go. We got lesson 10-3 two-way tables. This is my second go at it because I had a typo in here. So I made it halfway through before realizing I had a typo. It was fun. Anyways, take two. Did you notice that the last video that I did, everything looked blurry for some reason? I don't know. Hopefully this one does. It looks fine on my screen right now. We'll see. Anyways, we're doing two-way tables. Now, in the last two lessons, we were looking at data that was numerical, meaning that everything had like a number associated with it. Like one of the problems we were doing was the kids who were who were doing archery, right? So we were looking at two variables. We were looking at distance, and that was measured in a number. It was measured in the number of feet. And then our y variable was percentage of shots hit, right? So that's a number, percent. We could put that as a number on there. So that's numerical data. You can do like height, weight, age, I don't know, a whole bunch of different things, temperature, as long as it's a number. That's numerical data. When you do numerical data and there's two different variables that you're comparing, you usually want to use like a scatter plot. Everything is a number. Everything works out great. But not everything can be boiled down to a number. There's a lot of other things that you would do that is non-numerical, and we would call that categorical data. Categorical data usually is like based off of favorites or something like that. Like, what's your favorite restaurant? Well, there is no number for Chipotle, right? I mean, you could say it's 5. I don't know, whatever. Number your own restaurants. What? I don't know. In-N-Out? I don't know what number that would be. So there's no number for those. Now, you would number like the number of people that picked that, but the variable itself, there's no number that is associated with it. Your favorite color. There's no number for purple. Like if everybody picks purple, which would never happen. But if everybody picks purple, there's no number for purple. You can say 10 people liked purple, but purple itself doesn't have a number associated with it. So owning a type of pet, blood type, these are all different things that would be non-numerical. They'd be categorical data. When we have data that's categorical, we probably want to set them up on a two-way table instead. Now, two-way tables are going to look at the frequency, how many times they happen, of two different events. Both the columns and the rows are going to add up. Here's our first one that we've got here. Out of 32 students in Mr. Math's third period class, 8 of them own a cat, 17 of them own a dog, and 10 of those students don't own a cat or a dog. So, owning a cat is not a number. It's a category. You either own a cat or you don't. Owning a dog, not a number. It's a category. You either own the dog or you don't. Now, we do have numbers, but this is how many own a cat. The cat itself is not a number. This is how many own a dog. The dog itself is not a number. The number of owners of dogs, we can total them up. Now, the nice thing about these graphs or these tables is they add up side to side and they add up and down. So here we've got 3 numbers so far, and then our grand total of 32. So we've got 8 students having a cat, 13 having a dog, and 10 don't have a cat or a dog. There's something really weird about those numbers. If I take 8 plus 17 plus 10, that adds up to 35. But wait, didn't I say there were 32 students? Now, we didn't have 32 invisible students or 35 invisible students, like 3 extra students floating around the classroom or ghosts or anything like that. There has to be something else going on in the problem. How can we have 8 cat owners, and this is all correct information, it's not like we made a mistake somewhere. 8 of them are cat owners, 17 of them are dog owners, and 10 don't have a dog or a cat. Do you see why we might have a little bit more in here? Why there's 3 extra over here? The reason is it's possible to be both a cat owner and a dog owner. So if you own both animals, you would show up in both of these groups. You'd be double counted. So this is telling me I have probably double counted 3 of the students. 3 of them should own a cat and a dog. So you are double counting students who own both. And that's why we're over by 3. So as we fill this out, let's look for that and see if there are 3 students who have both a dog and a cat. Let's see what happens. All right, so we have 32 here. That's our grand total. 8 own a cat. So here's owning a cat. The total is 8. 17 own a dog. Here's owning a dog. The total is 17. 10, no dog, no cat. So no dog, no cat. Here's the 10 right here. We can now fill in the rest of the table. So if I've got 8 that own a cat, that would indicate to me that 24 don't own a cat. Because if you own a cat and don't own a cat, that should add up to 32 because everything adds up going this direction. Now, if you own a dog, there's 17 of them, and there's a total of 32 students, that would mean that 15 of the students don't own a dog. And we can keep on adding up and down, side to side to fill in the rest of the table. For instance, if we know that 15 people did not have a dog, and we know that of those people who don't have a dog, there was 10 that don't have a cat, that means this. 5 cat owners don't have a dog. And now we've got 5 plus 10, that's 15. Let's go this direction. We had 8 cat owners. Of those 8, 5 don't have a dog, which means 3 do have a dog. Going this direction, if 3 have a dog and a cat, and there's 17 dog owners, that means 14 would have a dog but no cat. And then it still adds up going the other direction. 14 plus 10 is 24. So we filled in the rest of the table. Now we're going to do a lot more with these tables, but just for today, we're going to just learn how do we set them up, how do we plug in the numbers, how do we double check our answers. Oh, and by the way, look at that. Cat and dog, 3, just like we said. The difference between 32 and 35 is 3. All right, so if you're feeling saucy and you want to try this out on your own, you would pause at this point. We've got 50 students from Grant Ridge. They go on vacation to Florida and visit several cities. 40 of the students go to Orlando, Disney World. And 18 visit Cocoa Beach, which isn't too far away. 9 of the students go to Orlando and Cocoa Beach. All right, so fill in that data that we've already been given and then try to figure out the rest of it. Go ahead and pause if you want to be saucy and try it on your own. All right. Last warning, here we go. 50 total students. I'm going to put the total right here, 50. 40 go to Orlando. Here's Orlando. That means there were a total of 40 of them that went there. 18 go to Cocoa Beach. Here's Cocoa Beach. The total is 18. Goes here. 9 go to Orlando and Cocoa Beach. That's this one. They go to Cocoa Beach and Orlando. 9 of them go here. We can now finish up the rest of it. If 40 of them went to Orlando, that means that 10 did not go to Orlando. If 18 of them went to Cocoa Beach, that means that we have a total of 32 who did not go to Cocoa Beach. Let's keep going. If 40 went to Orlando in total, and of those 40, 9 also went to Cocoa Beach, that means 31 went to Orlando but not to Cocoa Beach, because 9 plus 31 has to equal 40. Going down here, of the Cocoa Beach people, 9 went to Orlando, which means 9 did not go to Orlando, to make 18 right here. For the people who didn't go to Cocoa Beach, if 31 of them went to Orlando, that means 1 of them didn't go to Orlando. Maybe they went to Miami or something other than Cocoa Beach or Orlando. There's more than just 2 places in Florida if you haven't been before. And there we go. Everything adds up going side to side and up and down. Last one. Go ahead. Be saucy. You got this. Try it out. All right, pause it. All right, here we go. Out of 100 students surveyed, 45 of them brought their own lunches from home. 73 of them sat outside during lunch. 36 of the students who sat outside didn't bring their lunch from home. Let's plug in the numbers. There's 100 students. I'm going to put it right here. 45 of them brought their lunch from home. Here's brought lunch, total 45. 73 sat outside during lunch. So sat outside, total 73. That seems about right. Just about everybody sits outside. It's nice out. 36 who sat outside, who did sit outside, didn't bring their lunch from home. Okay, sat outside and didn't bring their lunch. That's this group, 36 right here. Okay, that's all the information they gave us. We can now figure out the rest. If 45 brought their lunch, that means that 55 did not. Because 45 plus 55 is 100. If 73 sat outside, then 27 did not. Because 73 plus 27 is 100. Let's keep going. If 36 of the people who sat outside didn't bring the lunch, then that would mean that 37 sat outside and brought their lunch, because 37 plus 36 is 73. Going this direction, here's the brought lunch. 45 students brought their lunch. We already counted 37 of them right here. So that means that I've got 8 who brought a lunch and didn't sit outside. Last one, we've got 36 that sat outside and didn't bring a lunch, but there's a total of 55 students that didn't bring their lunch. So that's going to be what, 19? Yeah, because 8 plus 19 is 27. Everything's adding up and down, left and right. So on the next lesson, we'll just go ahead and start looking at probabilities. We can find the probability that somebody went to Cocoa Beach and Orlando. 90 out of 55 people, that's 18%. So we can do stuff like that. We can find probabilities based off of our two-way tables with categorical data. That's all I got for you. Math hard. Keep going strong. We're almost to the end of the year. Good luck. Bye-bye.